Hello Year 10, it's Miss Bailey here. In this video we're going to be continuing looking at limiting reagents. In this video we're going to be going a step further to consider that stage 2 of those 5 steps that we looked at last lesson, by pulling together what we know about linking mass, moles and MR to be able to calculate the moles of each reagent for ourselves. So please make sure that you have the attached worksheet ready. So I'm going to go through the worked example. We will then do a redo of our question 1, just like how you did for the other worksheet, pausing the video once you've done a step and checking if you've done it correctly. And then there are 3 questions for you to be having a go at afterwards. So this first question, which you can be filling in on your side by side after we've gone through it. So the first step is to write a balanced equation for this reaction. So sodium hydroxide is reacting with nitric acid, and so what we're going to get there is a sodium nitrate salt plus water. So acid and alkali neutralization reaction forming a salt plus a water. So double check that this is balanced. It is. So then our ratio is a 1 to 1 to 1 to 1. Then our step 2 is to use our masses and our MRs to get our number of moles of substance. So we've got 10 grams of each of these substances. So we now need to work out what the MR is for each of those using our periodic table. So the MR of sodium hydroxide can be done by doing 23 plus 16 plus 1, which comes out to be 40. We can get our MR of nitric acid by doing 1 plus 14 plus 3 lots of 16 for our oxygens, and that comes out to be 63. So to get our number of moles, we need to do our mass divided by our MR. So 10 divided by 40, and that comes out to be 0.25 for that sodium hydroxide. And then for our nitric acid, 10 divided by 63 gives us 0.16. So at this point, we are now at the point we were for our previous worksheet, where we've got the number of moles of each of the substances and the ratio in which they are reacting. So we can pick one of the substances. So let's say sodium hydroxide as it's first in our equation. So with that 0.25 moles, how many moles of nitric acid would we need to react exactly with that 0.25? So because it's a 1 to 1 ratio, we would need 0.25 moles of nitric acid to react exactly with that amount of sodium hydroxide. So we then look at this amount of our nitric acid, and we see that 0.16 is less than 0.25, and therefore our sodium hydroxide is in excess, and this being less is our limiting reagent. So when we're looking at step 5, our less was our nitric acid there, because this is less than what is required. So we're now going to have a look at the question 1 on the side by side. So if you have a go at the first step, so writing the balanced equation, pause the video and then press play to check your answer. So we've got sodium reacting with fluorine, and we're going to make sodium fluoride. So we now just need to balance this. We've got 2 fluorine atoms on the left hand side, we're going to need 2 on the right. We now need more sodium atoms on the left hand side, so the 2 needs to go in front there. So now you can do the first step of writing the ratio of the substances of the balanced equations. And so that's at 2 to 1 to 2 ratio. So pause the video now whilst you use the masses from the question and the MRs from the periodic table to calculate the number of moles of each of the substances. Okay, so our masses is 15 grams of sodium and 20 grams of fluorine. Our relative formula mass of our sodium is 23, whereas our relative molecular mass of our fluorine molecule is 2 lots of 19, which is 38. To get our moles, we then do our mass divided by our MR. So for sodium, 15 divided by 23, which is 0.65. And for our fluorine, we are doing 20 divided by 38, which is 0.53. So if you now complete stage 3 by picking one of those amounts of substance and use it to calculate how much of the other substance would need to react it exactly. So again, if we pick one of our substances, so again I'm just going for the first one in our equation, doesn't matter which one you choose so long as you're doing the same thought process. So with this 0.65 moles, how many moles of fluorine would we need in order to react exactly with it? So it's a 2-to-1 ratio, so we would need half the amount of sodium in order for that to react exactly, and so what we need is 0.325 moles. So if you now pause the video whilst you complete stage 4, looking at how much we need of that substance to how much we have of that substance. So we can then compare 0.53 to 0.325, and we would see that this is greater than 0.325. And if you now pause the video whilst you determine which of these substances, the sodium or the fluorine, is the limiting reagent and which one is in excess. And therefore this is in excess and this is limiting. So we have more of the fluorine than we need, and therefore sodium is our limiting reagent here. Here is a reminder of those 5 steps. So have a go now at questions 2, 3 and 4. Your class teacher will be able to support you if you need any help. Thank you all for watching and see you next time.